We're at gotomath.com. Anyway, let's click on the calculus. Go down to definite integrals by the definition. So if you've looked at indefinite integration, we're going to be doing definite integration, which we're not going to be using the definition to find the integral down here in this section. But much like up here when we did the rules of differentiation, we did a few examples of finding the derivative by the definition. Well, this is similar. Alright, kinda. Anyway, let's just click on that and get busy because we got a lot of work to do. So we'll click there. Let's scroll down, see what it says. It says, woo, what is that? So we got the integral sign going for our limits. Lower bound is 1, upper bound is 7. Here's the function, 6x dx. You might have already seen this, hopefully you have. And then we're going to figure out what in the world all this stuff is by focusing first just on the summation here. Alright, so let's go ahead, write that down. We're going from 1 to 7, it looks like. Alright, so I'll go ahead and you know what, we'll write it right up here kind of small. So we're going from 1 to, oh, did I mess that up already? No, that's right, 1 to 7. 1 to 7. Boy, my memory's bad news. 6x. I should have probably wrote it down. 6x dx. So this right here is what we want to find. But however, we're going to use the definition, or this way of doing it, going from I to 1 to n. This would be the n subintervals. Okay, subintervals. And then we've got the function, which is actually 6x, but we're going to plug in ci and then delta x. Alright, so first thing we're going to do is work on this piece here, but let's find what delta x is, okay? So delta x is the change in x, and that's going to be your, this would be like b, and this is a, so you'd say b minus a over n, but I'm going to say 7 minus 1 over n. Alright, n's the number of subintervals. So I'm just going to kind of quickly sketch this out here. We're not going to get into a whole lot of detail on this. But if I'm trying to find, if we were looking at, let's say, the area underneath this curve right here, alright, finding the area under this curve, what we could do is we could chop this thing up in, let's say, 3, let's say this is your lower bound. We'll say that this is 1 and this is 7. And we would chop this up, let's say, into 3 subintervals and find the area of this box. And this is not going to be a very nice picture. And then let's say we're finding the area of this box and then add it to the area, let's say, of, we're going to stretch this one out here, the area of this box, and we just add all 3 areas up, and that will give us an approximation of the area under the curve, right? An approximation, because we'd have some error here because the top of these boxes here are not inside the curve, okay? But if you could imagine, we did, now this is just 3 boxes, so n would be, that would be taking this difference here and dividing it by 3. Okay, you take the difference, divide it by 3 right here. Now what we're going to be using is called the right endpoint. Now the right endpoint would be the right hand part of this box. You see this? This is where your f of x, this is definitely not a very good picture, but this is where for example, your f of c of 1, let's say. Okay, f of c of 1, alright, and c of 1 means that would be the first subinterval. And so to actually find this distance right here, okay, so c of 1 is going to be, we would start at 1 plus, and the delta x would be this distance right here, the bottom part of this box. Okay, that's your delta x, the bottom part of this box. So we would add the bottom part of that box right there, right? So in this particular case, you would have, what is this, 7 minus 1 is 6, okay? And if we let n be 3, So in other words, and you can simplify that down to 2, right? You could simplify that down to 2. So 1 plus 2. And then of course, this I right here, all right, this I right here would be, that's how many boxes we would go over, right? Um, let's see, if I added 3 to this, right, if the third box, 3 times 2 is 6, and 6 plus 1, that would give us right here at 7. See that? So anyway, it's not that bad, I promise. Um, put an I right here. Okay, so I is the number of boxes over. 1, 2, 3. Okay, but anyway, so C of 1, as you can see here, would be the first one. Of course, I would be 1, so this would be 3 right here. We would be going over 3. I should write bigger. This is terrible. Anyway, we would be going over to the 3, and then you would take 3 and plug it into the function, right? You take 3, plug it into the function, and that would end up being 6 times 3 is 18. And so we would, if we're trying to find the area of this box, so this right here, this y value is actually 18 times the width of the box. The height of the box is 18. The width of the box is going to be the 3, right? That would be this guy right here. We let the first spot, let I be 1, right? And so you would say 18 times 3, get that number, right? Which is what, 54, 24? Yeah. So that would be the area of the box, would be 54. And then we'd go over and do the next one. So we'd let I be 2 this time. Then take that number, plug it into the function, okay? That would give us the height of this box. And then we do it again to this box. Then we just add all 3 of those numbers up, and that gives an approximation up underneath the curve here between 1 and 7. Okay, that's all there is that's going on here. However, if we let me erase this. I tried to do some erasing there, it didn't work out. Anyway, if we actually between 1 and 7, aren't we? 1, and let's say this is 7 right here. However, if we were to let these boxes get smaller and smaller, what's going to happen? We're going to get a closer approximation to the actual area. All right, so that's the whole idea here with the limit part of it, is we let the number of subintervals, in other words, we let there be an infinite number of boxes. I mean, I know that sounds nuts, but that's what the power of the limit is. If we let these boxes let n go to infinity, in other words, there's an infinite number of boxes here. In other words, these boxes are extremely, 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 extremely small. Well, then we get closer and closer to the actual area up underneath the graph. And actually it's equal to this guy right here, because this is going to tell us the exact area under the graph. All right. Well, anyway, that's it in a nutshell, and that took 8 minutes. So, all right. Well, let's go ahead and do this right here. Okay, let's actually work this out. Let's find out what this area is. So we got our delta x. Okay, our delta x is actually going to end up equaling 6 over n. Okay, so that's our delta x. Now our CI is going to be this right here. All right, except we're going to simplify this down to 2i. Actually, it's that one right here. But so let's just come over here and let's go ahead and write some stuff down. So we're going to start with the first subinterval and then go to n. All right, and so we go ahead and actually let me go ahead and just write out what f c of I is equal to. So here's our function. Our function, we'll go ahead and write this out. Our function is 6x, and when we go to plug ci into it, it's 6 times ci is going to be 1, okay, plus, and then this part here is actually delta x and then I. And so delta x is 2. I mean, delta x is 6 over n. I'm like losing my mind here. 6 over n, okay, and right, and then times I, yeah, okay, so there it is. So that's our CI right here. This should be an n right here. I think I was just doing an example for this last problem. Alright, so I'm going to try to write a little neater. So there's our FC of I, and then we have our delta x, which is 6 over n. Okay, and so now we're going to come over here and just plug everything directly in. What we got, our FC of I is 6 times 1 plus 6 over ni, and then our delta x, which is 6 over n. Okay, and now what I'm going to do is I'm going to go ahead and this 6 over n and this 6 right here, we can actually, what we can actually do here is we can take these guys, since they're just coefficients here, and take them, multiply them together, and then pull them outside the summation sign. So this ends up and just getting them out of the way for right now. So this becomes 36 over n, and then I'll rewrite the summation symbol. Alright, and then we have 1 plus 6 over n I. Alright, okay. Now what I'm going to do is I'm going to go ahead and break this up into two separate summations, and I'm doing this because if you're seeing this for the first time, I'm probably not going to try to skip any steps here. So let's rewrite 36 over n. I'm going to put a big bracket here. Alright, and we're going to break this up into two separate summations. We got I is equal, going from 1 to n of just the constant 1 plus the summation I going to 1 to n of 6 over n I. Okay, now there's something else we can do. We can go ahead and take this 6 over n and take it out and get it out of the way, and we're going to do that too. Alright, I don't know what happened there. Got toggle between screens, and for some reason it's flipped over. Oh, I see what happened. Okay, it's been a couple weeks since I've actually made any videos, but I get a little rusty on this stuff. Okay, so we're going to write equals here, 36 over n. On the next video, I'm not going to go through all this detail on what's going on here, so this was your introduction, I guess. Let's go ahead and rewrite all this. We got the summation going from I equals 1 to n, right, of the constant 1. Now I'm going to go ahead and take this 6 over n out here, and it's just a coefficient. I is equal to 1 to n. Now there's something that you need to know, and that is the sum of I. Now exactly what is that? We're going to do a little demonstration over here. I equals 1 to n, and I have I. And what this actually means is you're plugging 1 into I, and then we're going, let's say 2, and I'm just going to define this to be 4 up here, let's say, and then plus 3, and then finally we're going to 4. So n is actually going to 4. However, we're just saying it's going to n. In other words, it's going out to however many places. All right, well, there's a formula for actually adding all this together, and it's n times n plus 1 divided by 2. This is the actual formula right here. So if n were 4, we would plug 4 in. 4 plus 1 is 5. 5 times 4 is 20. And 20 divided by 2 is 10. Now if you were to go ahead and add these up, 7, 8, 9, 10, isn't that cool? So there's the formula right there for just summing up some numbers. Well, that's exactly what this is. So what we're going to do is we're going to go ahead and take all this stuff here and just substitute it out. Now this is a constant, and the summation of the constant rule is if this is going to, if n was going to 4, you'd end up saying 1 plus 1 plus 1 plus 1. which is 4 times. So this just ends up becoming 1 times n, which is just n. So we'll go ahead and solve that. And then of course we're going to go ahead and write 6 over n here. It's just a coefficient, and this guy, this whole thing here is going to get replaced with this right here. So we end up with n times n plus 1 over 2. Alright, now there's one other thing. Let's not forget what's going on out here, and that is we got 36 over n. Boy, I'll be glad when we finish this. Like I said, we're not going to go into all this detail in the next one. So anyway, so now what we'll want to do here is simplify all this stuff down, then go back and throw it in front of that limit. Alright, we'll go back and throw it in front of the limit and then solve the limit. Okay, so let's look at this. These guys are going to cancel out. 2 goes into 6 3 times, so that's going to simplify down. So let's just go ahead and rewrite this. So we have n plus 3 times n plus 1. Okay, now we have this 36 over n. I'm going to go ahead and distribute this across. We might as well go ahead and get this out of the way. And let's just write that 36 over n right over here. How's that? Okay, and now what we'll want to do is go ahead and simplify this down. So we have, crossing that out, we're left with 36 plus, and now we'll go ahead and distribute this 36 across inside here. And let's just do some side work on some arithmetic over here. So we have 36 times 3, which is 118, or I mean 18, 9, 10. So we have 108. So this is going to be 108n, 8n, and then this will be plus 108 also. And remember, all of this is over n, right? Alright, now what you need to do here is go ahead and get this all into one single fraction. That means we're going to take this n and bring it up over here. So we end up with 36n plus 108n plus 108. And I sure hope that all this is right and I didn't make any mistakes, because I really don't want to redo this video. And this is going to be all over n. Okay, now let's go ahead and add both of those guys together. So we have 108 plus 36, and is that 144? I believe it is. So I'm going to go ahead and write that right over here. So we have 144n plus 108, and that's all over n. Now we have the limit as n goes to infinity. So there's a section in I don't know, horizontal asymptotes, or maybe it's the limit. Actually, I think it's under finding, or no, it's infinite limits. Maybe that's what it is I've done. It's been a while back, a few weeks back. But anyway, I think it's under infinite limits, limits at infinity. And so now what we want to do is go ahead and evaluate this. So since both of our leading terms have a power of 1, what you do is you just take their coefficients, put them over each other, and we end up with 144, and I sure hope that's it. Okay, so hopefully he was able to follow all that. Man, 18 minutes already. Where are we at? So the actual integral itself, let's go ahead and go back to the main page. Let's go ahead and hit answer. Ooh, there it is. All right, 144. So this piece right here is equal to 144. So, but of course it's also equal to that. All right. Okay, so let's just, I want to go back here, say a couple things here real quick on this. The first thing is you had to know this, okay? And this is obviously the big part of that. Understanding how to do that. And then this was something else, right? We got to know how to take the limit as n goes to infinity. Now, okay, we got all that. Let me go back to let's see here. No, these are limits going to infinity. I do have a section on that. Right here, limits at infinity, yeah. Right. So here's a section on what's going on. Now this particular one obviously is 0. But like the one we just got through doing, I'm right here. So you notice both coefficients are the same, and if they're both the same, you just take their coefficients. Both leading terms are the same is what I meant to say. They're both 4. I have a power of 4, so therefore you just take their coefficients. Alright, so if you've forgotten how to do that, okay, so that's important. One of the reasons why we learn that, I guess. But let's go back. Anyway, so there you are. Practice that. We're not going to, in the next video, I think it'll probably be 1.1-2 or whatever. We're not going into all this. So only the first video we're going into the detail, kind of the details. All right, come on by, go to math.com, and maybe I'll see you there. Bye.